Alright, FOR 242, time to go and move on from our canopy height model. Now that we've got that done, we've got our digital elevation model for the same spot. We want to save that instead of as a temporary layer. That's something we're going to work with. So right click, export, save as, and then GeoTIFF is the format we want. We want this to go into our week 7 folder. We're already in the right spot, and we're going to call that DEM stands 2 meter.tiff. Save. Keep all the defaults here. 2 meter by 2 meter resolution is correct. And OK. That'll load in. That's now the permanent one. This one can be removed. OK. First, let's make this a hillshade with elevation tint. So what I'm going to do is right click and duplicate layer. That's going to make a copy of this, not a copy of the whole data set, mind you. It's just a different set of instructions of how to access that same data set and display it. So let's make this one the hillshade. Double click, and then symbology, instead of single band gray, hillshade. And check the box for multi-directional. Apply. And you can see some of the imperfections in this data set. You can see around the edge of this river here where we had some laser pulses getting knocked around by the water. And we have some gaps here. That's okay. We'll just go ahead and work with that. And let's see the difference between the multi-directional and the traditional. So there's traditional hillshade, and there is multi-directional. And I like the multi-directional to have a Z factor of 2. Apply there. And I'm going to increase the brightness here. Try that, see how that looks. Brightness a little bit more. Apply there. Way too much. Back down here. Not bad, not bad. Now I'm going to go ahead and hit OK, and I'm going to move my elevation model on top of that hillshade. Then I'm going to double click on that, and we're going to symbolize it as render type single band pseudo color. And with this one, we're going to use the spectral color ramp. Apply. And I'm going to go ahead and invert that color ramp. Apply that. And you see this is getting thrown off by all these zeros being down here, and there's nothing actually in that range. So let's try a different mode. Quantile. Apply. Better. And you may choose to change the min-max value settings here to use the updated canvas as the statistics event. Apply there, and remember that's the tool that as you zoom in, it changes the lowest and highest values you see here. Right click and zoom to layer, and again it changes. Now what else can I do here? I can't see my hillshade, and I very much want to, so double click on that. And transparency, and let's try setting that to about 2/3 transparency. There we go. And we can experiment a bit. So there it is at 46%. Go all the way down to 14. That's not nearly enough. Move that back up around 50. Apply. I liked it pretty well around 40. So apply there. That looks pretty good to me. And again, because I changed that as I zoom in here, you see a little bit of checkerboard here. That's okay. That's just a sort of artifact of the data set. Not a perfect situation there. But you can see the roads. You can see some of the little turnouts for where the truck turns around here. You can see some of the cut and fill. So you see how it's been cut in here and filled in here, so you're not going too much up and down. And then going through there, doing about the same. So you can see all the roads, and let's right click and zoom to that layer again. And that's our full extent. Let's go ahead and make a slope model using this digital elevation model. That's under raster, analysis, slope. Input layer is your DEM. The ratio should remain 1. And I want to express the slope as percent instead of degrees. That's just sort of a convention. We use that more in forestry. You can use degrees as well if you prefer. Percent slope is rise over run, so if you go 100 feet and go up 10, that's a 10% slope. If you go up 20, that's a 20% slope over a 100-foot distance. We're going to save to a temporary file and run. When that's done, close that, and again we have this issue where we have things massively out of range. Double-clicking on that, and let's change that to, say, 150% maximum slope. Apply there, that's a bit better. That's not actually what we want to see. We want to see a categorized system. So we are going to go to single band pseudo color and classify here and change our interpolation from linear to discrete. And then we're going to change this. We're going to put in some values that actually make sense here. 6,000% slope doesn't, of course, but if we're going all the way up to this value, which is of course an error because there's errors in the data, we're going to change this. We just type in whatever we want, and we want less than or equals to 2 as our first one. And before we go farther, I'm going to invert that color ramp because blue makes better sense for low slope. That's where water is going to collect. After 2, let's make 10. So it's going to make that range 2 to 10%. Very gentle slope, but enough to maybe move water. After 10, let's go ahead and put in 30. And after 30, 50. So then we have under 2% slope, where water is likely to accumulate, 2 to 10% slope, 10 to 30, where it's perhaps steep but not dangerously so, and over 30 you're getting into where some machinery might not be suited to that ground. Over 50, that's another threshold. Maybe your most well-suited to slopes equipment is not appropriate to that. There are self-leveling harvesters, that kind of a thing, that can work on pretty steep slopes. Whatever their upper threshold is, gets the red color. Apply. And then, okay, so now let's go ahead and zoom in here, and we see we have some steep slopes here and here. If we wanted to navigate through them, we might be able to go up through there. A very small bit of steep ground there. Let's see how big that actually is. That's a little band, 3.2 meters. That might be passable, that might not. Something to check on the ground, but you have some potentially dangerous ground here. So you wouldn't want to put a skid trail straight along that. You could tip over. On the other hand, you have some flat ground here that could collect water. Let's go ahead and turn our canopy height model back on here and see what we have. So it looks like they went just under that slope. So not there, but the skid trail goes there. And let's turn that off. So that's placed in a way that makes sense for that terrain. Looking over there, you see all that blue in there. It looks like water might be standing here, lower slopes. And it looks like it might drain down through here. And that's kind of a wide thing. I want to check that out on the ground, find out what it is. Looking at the canopy height model, it looks like we have a bit of a strip going down there, but I'm not sure it's going right down the middle of it. So let's turn that off and on. Maybe it's going more or less. But if we see that spot right there, what is going on there? Interesting. So it looks like there's a strip on this side, but maybe not on this side. So I'm very curious about what that is. In any case, we also have satellite imagery there. We can look and see. Yeah, that's all conifer, so that looks like it's a wetter area up here. Yeah, so all conifer up there, and then maybe drains down to here. So that gets to go on the list of things to go take a walk. Find out just what's going on. Zooming all the way out, we can see there's a lot of steeper slopes around the edge of what looks like sort of a plateau in between these two rivers. And we can see there's some interesting channels here. Here's another one, so that's the first one we looked at. Here's the second. That's another interesting spot there. What does the air photo look like? Again, conifer and a run of conifer here. Turning that back off, turning our canopy height model on, you can see that conifer is sort of a strip in between these two stands. That might not have been totally apparent looking at just the air photos, like so. So even though you're still looking at a 2D map here on the screen, you really get the third dimension out of this, and you can see what's going on with the interaction between the terrain and the forest. So then if we zoom all the way back out here, then I can go ahead and add in the stands that I created before, place those on top, and give them a clear symbology. So let's double click on that. Set our simple fill to have no brush and make a goodly thick red line there as our stand boundary, and there we have it. So we can zoom in here and see that should definitely be cut out as a different stand, and let's go ahead and do that. Just like last week, right click and toggle editing, and we need to cut or split some features, and we want to split this one. That's definitely different here. So there's that. What else do we want to do? That one's fine, that one's fine. This is definitely different here. Let's go ahead and split that one there. And that one, let's zoom right in and get that just so there. missed a little bit, that'll be okay. And now those, I think, want to be together. So let's go ahead and merge those, keep those, and then we have to clean up the attribute table later, recalculating the area like before. But for now, we'll just go with cleaning up some of those boundaries. You can see that one there, that should be cleaned up there. You get to see a lot better with these height data. And this, well, there's a lot of different heights and ages going on in here, but it's all still sort of this one wet area, and we're going to keep that as it is. Some of these could maybe be merged. I would base that on ground analysis. If there's the same species regenerating underneath all of these canopies, then those could be considered all one stand. When we're done with those, we can right-click, toggle editing, save the edits, and we can make maps of our canopy height model, of our slope. And see if we're working in this stand, we have a lot of slope to contend with. If we're working in this stand, we have a lot of potentially wet ground to contend with. This looks like a pretty nice Goldilocks stand. We have some steep spots to maybe avoid with the machinery. This one, of course, wet. We know it's wet. This one, pretty tolerable ground there, except for that spot, and those two there. That one looks potentially dangerous, flat and likely wet. A lot of steeper ground here. So you might use a self-leveling machine here and a different piece of machinery here. And you can also make a map with just the elevation and hillshade, showing which stands are on the higher ground, which stands are on the lower. And you can also see this is a bit of a terrace or a stream bench, and you can expect a very different soil type here versus here. And again here, this is going to be different from that. Over here where we saw the photos of the big pine before, that's a big gravel pit there. And all of that gravel may well date back to the last glaciation and the melting of that glacier. Where these lines here are more likely a geologic feature, and potentially a dangerous thing to watch out for with equipment. So with LiDAR data, you can do a lot of the things that you do with air photos, but better, and you can also do things that you just can't do with an air photo.